All right, so we're back from a little hiatus, a 2-week hiatus from this. So we finished with 13.2. I looked at 13.3, and it's a nice lesson. Okay, I could have done it, but with the time frame, everybody's listening, right? So with the time frame, I just thought I'd hit some highlights of trig that I think you really need to know, okay? Because if I go too slow, we're going to miss some stuff. So there's just some things. Look, I don't expect, if you have this stuff in college, I don't expect for you to show up and like, oh yeah, I know all about that stuff. But at least it's recognizable, okay? That makes all the difference when you get to college, okay? You get there, they talk about something, and yeah, that's right, I remember something about that when I was in high school. That really makes a difference. And that's what we're trying to do right here, okay? And maybe you will remember a lot of this. So let's start. So we're not going to start with the law of cosines just yet. We're going to lead up to it, all right? And I think this is important. Some people may not think. Students probably don't think it's important, but I think it's pretty important that we lead up to the law of sines. So what I'm going to do is I'm going to take this triangle right here, and we're going to find the area of a triangle.
Mr. Hammert?
Yes, sir.
There's no triangle there.
You don't see a triangle?
No.
Do you see where it says college algebra?
Yep.
And you don't see a triangle?
No, well, looking at your time, it says 8:15 still.
Oh, really?
Yeah.
That's really weird. Well, I don't know. You're just going to have to follow along.
Oh, no,
Did it
never
just
mind.
pop
It
up?
just updated. There it goes.
Okay.
I guess my computer's slow. I don't know.
Okay. But you could always, I'm going to record it, so you could always look at it later if you're not sure. So if my voice doesn't match up with the pictures, then you can just watch the recording. All right, so what we're going to do is talk about the area of a triangle. We've actually done that before earlier this year. Do you remember that? We did the area of a few things. So the area of a triangle. Do you remember what the area of a triangle is off the top of your head? You should know this. You learned this when you were in 3rd or 4th grade. Give you a hint. It's 1/2 times the, very good, it's coming back, see? Times the base times the height. Do you remember that? The base and the height. Didn't you? I don't know. I can't remember. I haven't taught elementary, so I can't remember when you learned this. I don't know. At least in middle school, right? You definitely learned this in middle school. You probably learned this in elementary. But anyway, we're going to get a little more involved in this. So it's 1/2 the base times the height. So if I consider like the bottom of this right here to be the base, which one is the height? Is it this one right here? Is that the height? Is it this one right here? Is that the height? Anybody remember what the height is? The height is the perpendicular distance, okay, from a point to the base. So if I start here and I drop a perpendicular, which means a right angle, right, straight down to here, that would be the height. So let's put this in a different color. It's going to do a dotted line, but it might just look nicer with this if I just do a different color. If you wanted to put a dotted line, since you're doing it in pencil, okay, that would be, didn't quite exactly get to that point right there, but it's pretty close. So that red one would be the height, all right? And we said it's perpendicular, so what kind of an angle does it make down here? A right angle, okay? So that would be the height right there, and this, let's change colors again. This right here would be the base. I gotta get used to drawing on this thing again, okay? Everybody with me on this? All right, the problem is they're not gonna give you that, okay? They're not gonna give you the height. So we're gonna have to figure it out. So, but they could possibly give you an angle. So we know how to do some of that stuff. So let me get rid of some of this right there. Yeah, I'll keep that. I'll keep that right there. And let's put some letters in here. So let's call this triangle ABC. They do that a lot in geometry. So we'll call that ABC. Now, if we call this angle A, what do you think we're going to call this side over here opposite angle A? Side A. We'll make it a lowercase letter. All right? And over here, this is angle B. So what do you think we're going to call this big side over here? side B, right, little b. And then this AB right here, this side over here, that whole entire thing, not just from here to here, but that whole entire side, we're going to call C, letter C. Everybody with me so far? Now this B, don't get confused. This B and this B are not the same thing, all right? This A and this A are not the same thing. What is this A right here? That's the area, okay? So in fact, let's do this. Let's just put the word there, just so we don't get confused between the two. All right, that's pretty easy so far, isn't it? So what we're going to do, though, is we're going to find the area of this triangle. It's a non-right triangle, okay, that big triangle ABC. We're going to try to find the area of that big triangle. And you're thinking, well, what in the world does this have to do with the law of sines? Well, it does. It has something to do with it. So just bear with me right now. Let's see how we can approach this. Let's take a look at this. Let's use this angle right here. We could have used angle B. We could have used angle C. But we're going to use angle A right here. So in order to find the area of the triangle, let's call this letter C right here the base of the triangle. We okay with that? And then this H would be the height because they're perpendicular to each other. All right, so what we want to do is we want to use a little bit of trig to figure out what the height of the triangle is. And let's use this angle to do that, okay? So let's see what we can do here. Well, this is part of this right triangle, isn't it? So I know my right triangle trig, right? Well, we learned it at some point. Whether you know it now or not, it's a different story. But we did learn it at some point. You can always go back and look. So this is angle A. What is this H relative to this angle A? It's opposite. Very good. What about C? Yeah, but C goes where? It doesn't go from here to here. It goes from here all the way to here, doesn't it? So is side C part of this right triangle? No, so I'm not going to use that. But I do know another side of my right triangle. What is it? It's B. And what is B? It's hypotenuse. So what do I have? I've got opposite and I've got hypotenuse. Which trig function? Did you guys say this to each other all the way down to Tennessee? What is it? It's SOHCAHTOA, right?
Sin.
Okay, Cameron, what are you going to say?
Sin.
Well, there's no numbers right now, okay? Oh, did you say sin? Is that what you said?
Yeah.
Okay, yeah, it's sine. We never say sin. I mean, it's not because sin's a bad thing or anything like that. We just say sine, all right? So it's the sine. You are correct. It's opposite over what? Hypotenuse. Remember? SOHCAHTOA. So, S-O-H. Sine is the opposite of the hypotenuse. So what we're going to do is we're going to do this. We're going to take the sine of A. And again, what am I trying to do? I'm trying to find what H is equal to, okay? I want to find the height of this triangle. If I could find the height of this triangle, then I can find the area of this triangle. That's what I'm trying to do here. So the sine of A is equal to the opposite over the hypotenuse. All right, so the opposite is H over the hypotenuse, which is B. Now, I haven't solved for H yet, but now I'm ready to. I can solve for H, and it's pretty simple. If I solve for H, I got to get rid of the B. How do I get rid of the B? Multiply both sides by B. So what is H equal to? It's equal to B times the sine of A, of angle A. So that's what the height is equal to. That's really super important right there. Why is that important? Because what am I trying to do? I'm trying to find the what? I'm trying to find the area. That's my whole, I'm going to bring this down here. That's my whole deal, is I'm trying to find the area of this triangle. So what did I need? I needed the height. Well, I just found the height. Now, of course, we're going to have numbers in here, right? This is very general, very general. So we don't have specific numbers in here, but we're going to find the area, a general form for the area of a triangle that's not a right triangle. All right, so let's do this. Let's write area equals, let's fill in the stuff now, 1/2 times the base. Well, what's the base of this triangle? If I'm using this as the height, what is the base of that whole big triangle? We said it earlier. It's C, that's correct. All right, it's C. This is the base right here. Do you see that big long side right there? That's C, and that's the height right there. I'm sorry, that's the base, which is C, and then times the height. So let's do this. What is the base? Well, it's letter C in our picture, right? So I put C times the height. What do I know as the height? I know the height right here. So I'm going to write B sine of A. Looks a little ugly. We're going to make it look a little bit better. So we're going to write it like this. Instead of CB, wouldn't you rather go alphabetical order? I would. Just looks a lot prettier that way. So I'm going to go BC and then sine of angle A. That right there is super important. So I'm going to put a box around it. That's how we can find the area of a triangle if I don't know the height. Everybody got me? I could go through this process every single time to find the height, but if you kind of have this memorized, you could always use this every single time. Now, we dealt with angle A, but earlier I said you could deal with angle B or you could deal with angle C. So instead of going through this exactly the way I just did 2 more times, what I'm going to do is this. I'll make it a little bit easier for you. We're going to write 2 more equations for the area, but it's very similar. So one area would be this, 1/2 BC sine of A. Another area, now watch this. What if I used angle B instead? Let's take a look. Let's think a little bit about this. Instead of BC, look, I've got side B, side C, and angle A. So I got all 3 things there, right? I got A, B, and C. I got a B here. What do you think I'm going to put right here? An A and a C, exactly right. Okay? If you wanted to, you could take this whole situation, use angle B, say this is your base, and then your height would be like from here to here. You could redraw that 2 more times. I'm not going to just for the sake of time, all right? So, but what it basically comes down to is this. I'm going to get an A and a C right there. So let's put that in a box. All right, let's do one more area. Do you see what I'm doing now? I did all the work for one. Now I don't have to reinvent the wheel every single time. This is going to be true. And what else? What if I deal with angle C instead of A and B? What do you think is going to be right here? A and B, that's right. I'm going to put an A and a B right there. See, I've got my ABC here. I've got my ABC here, ABC right there. All right? Let's put a box around that. And that right there is how you find the area of a non-right triangle. Okay, if they don't tell you the height, back when you're a little kid, when you first learned this, they always told you the height. Okay, you never had to worry about it. They usually told you the base, they told you the height. All you had to do is go 1/2 times the base times the height. That was easy. But now it's a little more difficult because they're not always going to give you a right triangle. They're going to give you a triangle with certain sides, certain angles, and you're going to have to find the area of it, and that's how you find the area of it right there. Let's do an example. Let's do this. I'm going to use, let's use this triangle right here. And then let's see if I remember how to do this. Do I go to transform? I think. Click that. Yep. Flip vertically. Yeah, that's what I want. Well, let's flip it again. Horizontally. Yeah, that kind of looks like, looks like the triangle that I have on my picture right here. All right, and let's make it look, it's not exactly like that, but that's good enough. Who cares? May not be to scale, but that's what we have. All right, so here's the example. This is example 1. So we're going to find the area of the triangle. That's what they ask you to do. Find the area of this triangle, of triangle ABC. Remember what the title of this lesson was? We haven't even talked about that hardly at all, okay? The law of sines. We use the sine to find the height, but we're eventually going to get to it, all right? So just bear with me. So this is going to be angle A. You'll be so excited. Say that sarcastically. All right, this is not exactly the way it looks. If you want to look in the book, the triangle looks a little bit different than this, but it's good enough for us. And they give you a couple things. They give you that this angle B is 120 degrees. Doesn't look like quite 120. Looks maybe a little bit more than 90, but we'll call it 120. We'll say that's 6, and they call that feet. And then they'll call this one 5, and that's feet. And we want to find the area of this triangle. Okay? Well, what is the area of a triangle? The area of a triangle is 1/2 times the base times the height. Would you agree? Or in this situation, we're going to use this angle right here, angle B. So we're going to go what? Sine of 120, right? Because we know what it is now, right? It's an actual specific number. So it's 120. And what do we do here? If this was B, what do we do here? A and C, right? Which are the other two sides. This would be B. This would be side B right here. So we don't use that. We just use the other two sides. So whatever angle that we're taking the sine of, we just take the other two sides and we multiply it here. So that would be what? 6. I could put that in parentheses. 6 and 5. That's supposed to be an S for sine right there. And that's it. That's how you find the area of a triangle. Well, it's not it. You got to plug it into a calculator. But once you put it into a calculator, that's going to be your answer. That's how you find the area of this. Wow, that was pretty easy, wasn't it? As long as you knew what the formula was, okay, and most of the work was just developing the formula. But now you know the formula. Just use the formula. You don't have to reinvent it every single time. Just use it. So what is this? This is 6 times 5 is 30. Half of 30 is what? 15. So it's 15 times the sine of 120. And if you work that out in a calculator, it says to approximate it to 1 decimal point. Both of you? Okay. Now it's area. So is it just feet? No. Area is always what? Feet squared. Okay. So the area is equal to 13.9. I shouldn't really say equals. We rounded it. So what should we put here? Approximately equal. I wouldn't mark that wrong or anything like that, but I'm teaching it, so I might as well be particular about it. All right, so that's 13.9 feet squared. So that's what the area of that triangle is. You with me so far? Yeah. All right, well, let's get away from that. Let's go to this. I'm going to grab all these so I don't have to rewrite them all again. Copy that. Scooch this up a little bit. Put that back here. And let's just scooch it up to there. All right, so we got these 3 things. What I'm going to do now is we're going to develop the law of sines. All right, so bear with me. This is all the area for that same triangle, okay? Remember we used that triangle, we used angles A, B, and C. So what do you think might be true about all 3 of these things? They're all equal to the area of that one particular triangle. So what do you think might be true about all 3 of these things right here? If they're all equal to the same triangle, they must all equal what? Each other. Would you agree with that? Because, look, this is equal to area. This is equal to area. It's the same area, right? This is equal to the area. Again, it's the same area. It's just 3 different ways to find the area of that triangle. So all 3 of these things must be equal to each other. So let's do this. Let's set them equal to each other. I'm not going to ask you to do this on a test or a quiz or a homework even. I'm just developing. And when you get into math, if you ever take any, besides your basic math class that you have to take, if you take anything like an engineering or anything like that, You're going to have a lot of math teachers that are going to show you where you got these formulas from, okay? And I think it's pretty important to understand where you get them from. Some people may not. Some people might just, look, just show me the formula. All I want is the right answer and get out of here. That's all I want. I get that. I understand that. But the more you learn, okay, the more that you're developing your mind, the more you're going to think, how in the world did they get that? Because I used to teach this. When I teach this in geometry, I probably would not go through what I'm going through right now, okay? But when I get to Algebra 2 or I get to college algebra or pre-calc or something like that, I think it's really important that we see this. So remember what I said? All three of these little equations are equal to each other. So instead of setting them equal to area, I'm going to set them equal to each other, all three of them. That's kind of weird because we don't usually see three things being set equal to each other, but we're going to now. See what I'm doing? Okay. Because this formula that we're going to get is a little bit weird looking compared to formulas you've seen in the past. It's not really that hard, but it's just different. All right, so I got all this stuff right here. So what I'm going to do now is I'm going to, and this is probably where you might be with me so far, but this is where I might lose you. All right, but I'm just going to show you what I'm going to do. What I want to do is I want to turn this, like I see some things that are in common. I see the halves that are in common, right? So I could divide everything by a half. That'll get rid of the half. I see a B here and a B here. So if I divide everything by B, that'll get rid of a B. I see a C here and a C here. If I divide everything by a C, I can get rid of the C. Same thing with the A. I can get rid of the A. All right, you with me on that? So what I'm going to do is this. I'm going to divide everything. Let's do this in a different color. I'm going to divide everything by a half. That'll get rid of all the halves. That'll make it nice. I'm going to get rid of the A's. That'll get rid of all the A's, the little A's up here. I'm going to get rid of the B. That'll get rid of all the little b's up here, and I'm going to get rid of the c. So dividing by 1/2 ABC will get rid of a lot of stuff. It'll just make it look a little more compact, a little bit nicer, okay, a little bit easier to look at. So I'm going to divide everything by, and remember, whatever I do to one thing, I can do to everything. As long as I do it to everything, I'm allowed to do this. So that was a little weird, right? You know, you're probably thinking, why in the world is he doing this? Well, there's a method to my madness right here. So watch this. If I take this and divide it by this, what cancels out? The half cancels out. What else cancels out? The B. What else cancels out? The C. So what am I left with? And this is what we want. Okay, so what's left on top? All those things canceled out. What am I left with here? The sign of A. But what do I have on the bottom? I still have a little a on the bottom. You with me? Let's come over here. I'm not going to do it in red, but what happens? The halves cancel, the A's cancel, the C cancels. What am I left with? This right here, this thing that I'm writing right here, is actually the law of signs. We're finally there after what, half an hour or so of teaching this stuff? This is actually the law of signs. Have you ever learned the law of signs before? Probably not. You should have in Algebra 2. All you guys took Algebra 2, correct? Yeah, you should have learned, but doesn't look like you got that far. So, because you didn't do any trig at all, right, in Algebra 2? Yeah, so you probably didn't get to this. So look, the A's cancel and the B's cancel, and what are we left with here? Sine of angle C over side C. Well, that's pretty important. So what do I put when it's important? Put a little box. Put it in a box. That right there is called the law of signs. Put a little exclamation point because I'm so happy we finally got there. All right? So that's the law of signs. You could, if you wanted to, and sometimes I do this. Sometimes you might catch me doing this. You could flip it and rewrite it like this. It doesn't make any difference. Sometimes it might be easier to do it like this, depending on the problem. Whoops. See what I'm doing? Just flipping everything. It's the same exact thing. Right? It's just sometimes the math the algebra is just a little bit easier if we write it like this. So you can write it either way. It doesn't make any difference. Some books might write it with the A on top. Some books might write it with the little a on the bottom. Okay, like this. All right? Everybody with me? Yeah? All right. Now, let me give you a little preface before we do our example, because we're going to do, how many examples? We're just going to do one example, and then we'll be done, okay? So let me just do a little bit with this, show you how we're going to use this. Because you're not used to seeing three things equal to each other, are you? All right, you're used to seeing this is equal to this. Bam, you're done. But now we got three things equal to it. Matt? I sure do. Thanks. I just put that in there so you see if you're paying attention. Not really. Just kidding. Thanks for that. All right, there we go. Now that looks a lot better. All right. So now what we're going to do is, we'll just keep this version of it right here with a little a on top. What we're going to do is we're going to pair them up. Remember I said you're used to just seeing one thing equal to another thing? That's basically what we're going to do here. So when we actually use the law of signs, we're not going to use all three of them at the same time. We're just going to pair them up. So you could write it like this. And again, you could put this sign on top if you wanted to. All right, so that would be one version. Or, you see what I'm doing now? See, I'm just pairing them up. So I'm going to have three different ways you could write this. Or I could write A over sine of A equals, what do you think now? I used the B. I said A is equal to B, so now A is equal to what? C over the sine of C. Or, what's my other thing here? I already used A twice, right? So what am I going to do? So I'm going to go B sine of B equals what? C. And that's all the options I have, isn't it? Okay, that should be a capital C. Let me make that a little bit bigger. All right. So if you wanted, you could put that in a box, that in a box, and that in a box, like that. So this is what we're really going to be using. Okay, it just looks nice and compact like that. All right, but we're going to be using them. We're going to pair them up. All right. So now we're finally here. After all of that, we're finally here to figure out how we're going to use this thing. So let me just draw my own triangle. So right there. And then have one come up about something like that. And then another one about like that. All right. Doesn't have to be perfectly scaled. Doesn't really matter. But let's see what we've got. We're going to call this triangle ABC again. They love their triangle ABCs in math books. So we're going to give some, that 5 looks terrible. Let's try this again. It's a little bit better. So we're going to say that A is 45 degrees. We're going to say that C is 55 degrees. We're going to say that this side right here is of length 12. And that's it. That's what they're going to tell you. And what they're going to ask you, this is example 2. Example 2. They say to solve the triangle. What in the world does that mean? Solve a triangle. I didn't know if you could solve for a triangle. What do you think that means? Here's all the stuff they give you. If it says solve the triangle, what do you think they're asking you to do? Find the missing angles and the missing what? Sides, that's right. So what do you think the very easiest thing to do? Before you even walked in this room, you should have been able to do this, is to find one of the things. What is it? Angle B, absolutely. So let's find angle B. We're going to have to find both things. So let's call this something right here. Instead of calling it BC, let's give it a letter. What letter do you think we're going to call this side right here? Small a. And then what are we going to call this side? Small b. All right, you with me on that? Because it's opposite B, it's opposite A. So that's what we want to solve for. We want to solve for angle B, we want to solve for side A, and we want to solve for side B. We good? All right, so let's do it. Let's solve for angle B. That's pretty easy. So what do? It's just 180 what? Minus, what is that? 55 and 45? That's 100, isn't it? So what's that? 80. Told you, you could do that before you walked in the door, right? So that's what that is. Let's put this in a different color just so we know this is one of our answers. So 80 degrees right there. All right, so we got one thing down. That's good. We could circle it, couldn't we? Let's circle it. That's one of our answers. Now we got to solve for A and B. Now, before you walked in the door today, probably you wouldn't be able to find A and B. You probably could have, though. You probably drop this straight down, find the height, do the sign, blah, blah, blah. You could do that from scratch if you wanted to, and then solve for A and solve for B. But we have a little bit better way to do it now. We have the law of sines. Now, I got to tell you, the law of sines is a little more complicated than what we're doing right now. This is the easiest version of the law of sines. I debated last night when I was going over this to teach you the second part of it, but I don't think I'm going to just because of our time frame. If we had a month left, I probably would. But there's a thing called the ambiguous case. If you want to look that up, I'm sure you won't. But if you want to look that up, the ambiguous case to the law of sines, it gets a little bit tricky. And it's kind of hard to teach a little bit too. But just for the sake of time, we're not going to go through that. I'm going to give you a worksheet today. And one of them, I'm not going to give you the whole worksheet to do because some of the problems has the ambiguous case in here. And it's a little bit confusing. I just don't have enough time in one class period to do that. I barely have enough time to do this. So I'm going to give you the, quote, easiest ones of the law of sines, okay? So don't think you're going to go to college and know everything there is to know about the law of sines. There is still more to know about it. We're just not going to cover it just because of the sake of time, okay? Everybody good with that? You're probably very happy with that because I'm going to give you the easiest ones to do anyway, so you should be good with that. All right, so let's figure out what we're going to do here. We know one of the sides, right? And we know all three angles. So I could go, and it doesn't really matter if I go A over B. Watch. For some reason, I like putting the little a on top instead of the sign of A on top. I don't know why. It doesn't matter. But let's do, I'll tell you what, let's call it C. Is that what you're going to say, Matt? Yeah. Let's do that. Okay. Now, why did I do that? Because look, if I'm going to solve for something, I need to know 3 out of the 4 things. Would you agree? So I need to know side A. Do I know side A? Nope. So that's what I'm going to solve for right now. I'm going to solve for side A. Do I know angle A? Yep, 45. Do I know side C? Yeah, if here this is angle C, I know side C, so I can put that in there. Do I know angle C? Yep. So all that stuff I know. I know 3 out of the 4 things. You with me? So that's why I can solve for A. Now, what I'm going to do, and the reason I like to write it like this sometimes, if I solve for the side, I got to get A by itself. How do I get rid of this sign of A? Well, I'm dividing by it, so what do I do if I divide by something? How do I get rid of it? I multiply by it, correct? So what am I going to do over here? I'm going to multiply that C by what? The sign of A over the sign of C. That's the hardest algebra you got to do on this problem, at least this particular one right here, okay? Everybody see that? You could do this. You could cross multiply. Remember cross multiplying? When you have 2 fractions equal to each other, you could cross multiply. You're eventually going to get to this anyway, right here. Well, let's stick the numbers in because we know what numbers we have now. Do we know side C? Yeah. What is it? It's 12. Okay, let's take the sine of angle A. What's the sine of angle A? Well, I should say this. What is angle A? It's 45 degrees. So I'm going to take the sine of 45 degrees over the sine of angle C. Remember, we always take the sine of the angle. Never take the sine of 12. All right? You don't take the sine of a side. You always take the sine of an angle. So it's the sine of angle C. What's angle C? 55 degrees. See how we knew 3 of the 4 things? Now we can solve for A. So what you're going to do is you're going to plug that into a calculator and you will get approximately, I shouldn't put any equals there, but that's all right, approximately 10.4. I don't know if this is in inches or centimeters or feet or anything, so I'm just going to keep it just 10.4. So that's what this side is right there. Now you could solve for side B. So let's do that. Well, we're trying to solve for B, so what am I going to do here? I'm going to put B over the sine of angle B, which I know. Now, what are two other things that I know? Well, I know A, which is 10.4, but let's not use that one because that's an approximation. Let's use the original information they gave us. So I'm going to use that 12 and that 55 again. So I'm going to put a 12 up here and then the sign of 55 down here. Let's move this up just a tad so we can see. And now we want to solve for B. So let's solve for B. The math is exactly the same. All right. So I multiply by the sign of B right here. So let's see what it is. It's, why did I put a B instead of the number? I don't know. Because I know what B is, don't I? So let's stick the number in there. If I could grab that thing, get rid of it. There we go. So that's the sign of 80 right there. So now let's put the stuff in here. So what do I get? I get 12. I multiply by the sign of 80 on both sides. And then, see, I got rid of that. And then that's all over the sign of 55. Work on that math. I know I didn't spend a lot of time on the algebra on that, but you should know how to do that kind of algebra. And now, once we put it into a calculator, we get approximately 14.4. We'll round it to one decimal place. All right, because you'll get some big old crazy number after it, so we just round it to that. And there we go. We just solve for the triangle. There's angle B, there's side A, and there's side B, okay, by using the law of sines. All right? I know that was a lot, but you can always go back and watch a little bit of it if you didn't understand it. So, our homework. I'm going to give you a worksheet right before you leave, and it's section 13.4, and it says practice at the top. Some of these say skills practice or something, and some just say practice. This one says practice. Now, you're only doing 1 to 13. I know you probably want to do them all, but you're not going to, all right? You're just going to do 1 to 13, all right? For those who came in late, if you did not take the quiz the last day before you went on break, you need to come to me today and take that quiz. If you don't come to me in a day or two, I'm just going to give you a 0 on it. All right, that's how it's going to work. We only have 2 weeks left, less than 2 weeks now, okay, and we miss a class each week. So that's what? Only 7 more classes of this. So make sure that you come in today and take that quiz. I told you the week before you left, if you don't take that quiz when we take it all together, you're going to have to take it the day you come back. All right, so you need to take it today. If you don't take it today, I'm going to mark points off if you don't take it today. And if you absolutely cannot see me today to take it, then you need to make arrangements with me, okay, and let me know why. Okay. Tell me when. Like the area of the triangle? Right there? You got 12.9? All right, let me do it. No, because I used different calculator. Let me see. Sine of 120. So I put 120 and then sine, and then I put times 15. Times 15. And you're absolutely right. I got 12.9 instead of 13.9. And technically it's 12.99. So you know what, I was probably, maybe I used a different angle than what the book did. Maybe I wrote it down wrong or something, but you're absolutely right. That's a good call on that. So it's 12.99, but if I round it to one decimal place, it should be what? 13.0 is really what it should be, according to the numbers that I have right here. Okay, so thanks for that. Appreciate it. I'm not going to take the time now because I don't have any time, but I might have messed something up. Or the book might have messed it up. They're known to make a mistake once in a while as well. So, okay. All right, let me close this out, and we'll be done.